Good morning, students. I am Dr. Shirley Edward. I am handling Advanced Digital System Design. As part of this Advanced Digital System Design, in this lecture, I would like to discuss about race condition and race-free state assignment. So what is a race condition? So during a transition in an asynchronous sequential circuit, if two variables change simultaneously, then there occurs a race condition. So in order to overcome that, we will move on for race-free state assignment. So there are two methods for race-free state assignment. So first one is shared row method. Second one is multiple row method. So with the example of flow table, we will discuss these two methods. So let us take this example flow table. So here, if we look at this flow table, there are four states, that is A, B, C, D. There are four states are there. So first we consider this shared row method. In this shared row method, we will first construct a transition diagram. So what is a transition diagram? So here, how the state transition is occurring, that is shown in this transition diagram. So initially, we will list all the four states. So here we have states A, B, C, D. So we will put the order as 0, 0, 0, 1, 1, 1 and 1, 0. In this order, we will assign the binary assignment. So now we will here if we look at the first row of this flow table. So if we look at the first row, first state is A. So A to B transition is occurring. So A to B. So here from 0, 0 to 0, 1. So there is only one state change. So there is no problem. We will mention here with the arrow marker. And here next A remains in this same place. So there is no problem. Here we will put A. That is a stable state. Then A to D. So here A to D is here A is 0, 0 and D is 1, 0. So only one state change, so no problem. Then A to A remains in this, since it is a stable state, it remains in the same place. Then B to B, and then B to D. So B to D, if you look at B has got binary assignment 0, 1, whereas D has got binary assignment 1, 0. So both the states are changing here. So there occurs a race condition. Both the binary states are changing. So there occurs a race condition. Then B to A. So B to A, if you look at, it is from 0, 1 to 0, 0. So here there is only one state change. So there is no problem. And then coming to C, the third row, C to A. So if you look at C to A, C value is 1, 1, whereas A value is 0, 0. So both the states are changing. So there occurs a race condition. Then C to B. So C to B, there is only one state change, so there is no problem. And then D to C. So D to C, if you look at, there is only one state change, so there is no problem. So if we look, this is how we construct the transition diagram. So now, here if we look at the transition diagram, there occurs a race condition. So we in order to overcome this, we will move on to this shared row method. So initially, we will consider this 3 variable K map. So in this 3 variable K map, we will first construct this 3 variable K map. Here we have 0, 1, and here we have 0, 0, 0, 1, 1, 1 and 1, 0. So this 4 states we will first write in a T shape, that is a normal T or inverted T. Anyway, we can write in any place we can write, but we have to write it in a T shape. So A, B, C and D. So we and the place value also we will mention here, that is 0, 0, 0, 0, 1. 0, 1, 1 and is 1, 0, 1. So like that we will mention the place value also here. So now what we will do, we will look at the flow table. So after writing this, we will look at the flow table. So here in the first row, A goes to B. So here if you look at this, A goes to B. So here 0, 0, 0 to 0, 0, 1. Oh, there is only one binary transition, so there is no problem. And A to D. So if we look at A to D, here A value is 0, 0, 0, D is 1, 0, 1. So there is a problem. There are two states are changing at a time. So now what we will do, we will introduce an intermediate unstable state. So the intermediate unstable state, we will name it as E. And here we give that, allocate the place here in this box. So here the box, what is the value? 1, 0, 0. So A goes to D via this E. And then here B goes to D. Again, we have to look for B goes to D. So B to D, here again only one state transition, so there is no problem. B to A, again one state transition, so there is no problem. And C to A, so if we look at C to A now, here 0, 1, 1 and A is 0, 0, 0. So again we will fix one intermediate unstable state named as F. So here F value is 0, 1, 0. So C through F it goes to A. So here there is only one change, one state transition. Okay, then what we will do, so C to B. So C to B also there is only one state change. And then what we will do, D to C. So if we look at D to C, here 101 and 011. So there is only here there are two states are changing. So here the D to C it goes via G. So G here it is 111. So here if it goes via G, there is only one binary state change in during every transition. So using this now, we will form this transition diagram. So here, if you look at this diagram, A to B and B to A, no problem. And C to B, also no problem, only one change. And whereas D to C, it goes via G. And C to A, it goes via F. And A to D, it goes via E. So this is how we form the new transition table. So now what we will do, with the help of the already given flow table and this transition diagram, here we will form this modified flow table. So with these two as a reference, we will form this modified flow table. So in this modified flow table, we will write these states, list the states in the order it is present in this K-map. So we will write as A, B, C, D, C, F, E, D, G. And the place value also we will write it as such. So now here, if you look at this, so here first row, if you look at A to B. So A to B is, there is no problem. Here only one change. So A to B, we will write it as such. A is a stable state, so we will write it as such. So A to D. So if you look at A to D, this A to D goes via this E. So E state is 1, 0, 0. Only then there will be a single state change. So here what we will do, A to E, here we will mention, then from E to D. So here we will mention as E to D. Then what we will do, here B to D. We have to look for B to D. So B to D, if you look at B to D, there is no problem, only one state change. So directly B to D we can write. Again B to A. So B to A also no problem, we can write it as such. Then C to A. So if you look at C to A, what happens? C to A, it goes via F. So here F we will write, then from F to A. Then again C to B. So C to B, there is no problem, we will write it as such. Then F and E we had already written, and then D. So D to C. So D to C, here D to C it goes via G. So here G we will write in this place, and then from G to C. And the other remaining states we will put a dash, so that it means that it is unstable state. We do not know what is the value of the state. So this is the new modified with the state assignment. This is the new modified flow table using the shared row method. So now we will move on to the next method, which is multiple row method. So this multiple row method is a simpler method compared to the shared row method, but the disadvantage is it has got more, it will result in more states, whereas in shared row method the number of states will be less. Okay, so here in the multiple row method, here from this flow table we come to know that there are 4 states. So here in the 4 states, what we will do, we will take the same 3 variable K-map and we will write all these states in a sequence, that is A1, B1, C1, D1. Then what we have to do, we have to look for the complement. So if we take A1, A1 is 0, 0, 0. So what is the complement of 0, 0, 0? It is 1, 1, 1. So we here in the place of 1, 1, 1, we will write A2. Similarly, in the place of B1, here it is 0, 0, 1. So the complement is 1, 1, 0. We will write it as B2. Similarly, C2 and D2 we will write. So with this as a reference, now with this flow table as well as this 3 variable K-map as a reference, we will fill up this modified flow table. So here if we look at, we will write in this sequence, that is A1, A2, B1, B2, C1, C2 and D1, D2. So A1 is 0, 0, 0. A2 is 1, 1, 1. Like this in the order we will write. So here, if we look at this first row, A to B, we have to look at. So A1 to B1. So there is no problem, only one state change. A1 we will write as such, A2 also, from A2 to A2 we will write as such. Similarly, B1 to B1 and B2 to B2, C1, C1 and C2 to C2 and D1 to D1 and D2 to D2 we will write. Then here, this A to D. So A to D, if you look at, there is only one change, so no problem, we will write D1. Then A2 also in the same way we will write. Here if we take B1, B1 to D1. So B1 to D1, if you look at, what will happen? Here two states are changing. So what we have to do, first from B1 to D2 it will go. So if it goes to D2, there is only one state change. So D2, then what happens from B2? From B2 to D1, it can go. So there is only one state change. And then B to A, we will write as B1 to A1, B2 to A2. Then C1 to C1 to A1. If you look at, C1 is 0, 1, 1. A1 is 0, 0, 0. So C1 to, what we have to write? A2. Only one state change. Then from C2 to A1. So C2 is 1, 0, 0 to A1. Like that we have to write. Then C1 to B1, C2 to B1, B2. And similarly, D1 to C1 and D1 to C1. Here only one change is there, state change. Similarly, D2 to C2 and D2 to C2. So this is the modified flow table using multiple row method. Thank you. I hope you would have understood this modified row method.